Hi guys, in this video we will learn all about the vectors in C++. Like what is a vector, how vectors are implemented internally, how to create a vector object, how to initialize a vector with a set of elements, how to add elements in a vector, how to access individual elements from a vector, how to iterate over all the elements of a vector, how to remove elements from a vector either by index position or based on values. So this is going to be a complete vector tutorial. It will include all the information that you will need while using a vector in your application. For all the examples in this video, you can refer to our website thispointer.com. We will provide the links in the description box of this video. So let's get started. What is a vector in C++? A vector is a STL container which acts like a dynamic array. It can grow or shrink as needed and provides a number of useful member functions for working with the elements in it. How vector stores the data internally? A vector in C++ stores its data internally using a contiguous block of memory, just like an array. But an array is of fixed size, whereas the size of vector is dynamic in nature. What does it mean? When a vector is created, it initially reserves a small amount of memory to store its elements. As elements are added to the vector, it dynamically resizes itself by allocating more memory as needed. Therefore, it is also called as dynamic array. A vector stores the element in contiguous block of memory and keeps the track of number of elements currently stored in the vector using a size member variable. It also keeps the track of the amount of memory currently allocated for the vector using a capacity member variable. When the number of elements stored in the vector exceeds the current capacity, the vector automatically resizes itself by allocating a block of memory that is large enough to store the additional elements. This process is known as reallocation, and it can be done by copying the elements from the old block of memory to the new block of memory. This also makes vectors sometimes inefficient. Suppose you have a vector which contains 100 elements and its capacity is 150 elements. If you try to add more 100 elements into it, it will internally allocate a new block of memory of 300 elements and copy the existing elements into it and then add the additional elements. So the copying of those existing elements will be a time-consuming process. Although we can avoid this with a little trick which we will discuss later in this video. How to create a vector in C++? First, we need to include the vector header file, and then we need to declare the vector object by specifying the type of element it will store. The type here can be int, char, string or any other valid type. Once we declare a vector object with a type, then the vector object can store elements of that type only. For example, this is a vector of integer and can store integers only. Now suppose we want to store strings in a vector. For that we need to provide string as a template parameter while creating a vector object. So this is a vector of strings which can store strings only. We can change this template parameter to any data type. For example, to create a vector of characters, we need to provide the char as a template parameter while creating the vector object. So this is a vector of characters and it can store characters only. We don't need to provide the size of vector while declaring its objects because vector is dynamic in nature. It means it can grow automatically when we add elements into it. Also, it can shrink automatically when we delete elements from it. Let's see a complete C++ program to create a vector of integers. How to create a vector object and initialize it with certain values. First of all, we need to include vector header file. Then we need to declare the vector object. For that we will write std vector, and as a template parameter we need to provide the type of the elements that this vector object will store. Like if we want to create a vector object to store integers only, then we can provide int here. Or we can say vec obj. So this vector object will have integers only. Now if we want to create a vector of strings, then we can provide string here. Now this vector object can have string elements only. And if we want to create a vector of char, then we can provide the char here. This vector object can contain the chars only. Now let's come back to the integer vector. So it will create a vector of integer, but it will be an empty vector. We can confirm it by checking its size. Vector provides a function size to check its size or check the number of elements in the vector. Now let's run this code. It printed the size as 0 because it's an empty vector. What if we want to create a vector object and initialize it with certain values in the same line? In that case, we can provide the elements as an initializer list, like here. We provided 5 elements in the initializer list. This initializer list will go to the vector constructor and vector will populate all these values inside it. Now the vector object will have 5 elements. We can confirm this by printing its size. Let's clear the console and run the program again. Yes, vector has 5 elements. We can confirm this by printing the contents of the vector also. For that we are going to use the range based for loop. Vector object, and inside the brackets we will print each element. Let's separate each element by a comma. Once the for loop ends, we will print a new line character. Running the code, and yes, it printed the contents of the vector. Vector has 5 elements. So in this line, we created a vector and initialized it with 5 different elements. What if we want to create a vector of 10 elements but with similar value? For that we can pass 2 different values in the constructor. First is the number of elements that we want to insert in the vector. Let's say 10. And the value of each element. So we can say like 99. So it will create a vector with 10 integers and value of each integer will be 99. We can confirm this by running the code. Vector has 10 integer values, 99 in it. So these are the 3 different ways to create a vector. First one is the empty vector. The second one is by providing certain values in an initializer list. And the third one is initializing a vector with n similar values. How to add or insert elements into a vector in C++. We have already created some boilerplate code here where we have included the vector header file and created an empty vector. As of now, there are no elements in this vector, therefore its size will be 0. We can confirm this by printing its size. For that we will call the size function on this vector object and print it. Let's compile and run this code. As we guessed, it printed the size 0 because there are no elements in this vector. Now we will insert few elements in this vector. For that we are going to use the pushback function of the vector. This pushback function accepts an element as an argument and appends that element at the end of the vector. For example, we will pass 12 here because it's an integer vector, so we can add only integers inside it. So we pass 12. It should insert the element at the end of the vector and size of the vector will become 1. We can confirm this by running the code again. The size is 1. Basically the contents of the vector will be like this. Only one element, and that is 12. Now we can insert few more elements at the end of the vector, like 13, 14 and 15. So when the code will execute this line, it will append or add the element at the end of the vector. The contents of the vector will be like this, 12 and 13. Code will execute this line, it will add another element at the end of the vector, that is 14. After that, this line will be executed and this pushback function will insert the element 15 at the end of the vector. And the content of the vector will become, and the contents of the vector will be like this, 12, 13, 14 and 15. 15 will be added at the end of the vector. So the size of the vector will be 4 now. We can confirm this by compiling the code and running the executable file. And yes, the size is 4. Instead of printing the size, we can iterate over all the elements of the vector using a range-based for loop. Now let's clear the console and run this code. So it printed all the elements of the vector on the console one by one. An important point here, like instead of auto, we can use the direct const int reference here, because we are not going to modify the vector contents. Therefore we can fetch each value as a const reference. So this is how we can insert or add an element to a vector. But the pushback function adds the element at the end only. What if we want to insert the elements in between the existing elements of a vector? For that we are going to use the insert function of vector. Let's clear this code and initialize a vector with some default values, like say 21, 22, 23 and 24, 25. So this vector has 5 elements. We can confirm this by printing its contents on the console, and yes, this vector has 5 elements. Now we want to insert the element at the beginning of vector. For that we are going to use the insert function. Now insert function has multiple overloaded implementation. We are going to explain 3 different implementations. So first one is if we want to insert a single element at a specific position in the vector. For that, first we need to pass the iterator pointing to that position in the vector. As we want to insert the element first position in the vector, so we will say vector dot begin. So it will give us the iterator pointing to the first element of the vector. As the second argument, we will pass the value that we want to insert in the vector. Suppose we want to insert 99 at the beginning of the vector. So we will pass 99 as the second argument. If we run this code, it will show that it has inserted the element 99 at the beginning or at the front in the vector. So like instead of printing in a separate line, let's print in a single line. Let's clear the console and rerun the program. So value 99 is added at the beginning of the vector. What if we want to insert at the second place instead of beginning? So now the second place, the element is 22, but the index position of the second element is 1. Iterator begin points to the first element and we want an iterator pointing to the second element. For that we will add 1 in the begin. So now this iterator points to the second element of the vector and it will insert element here at the second position. All the elements after it, like from 22 to 25, will be shifted by 1 position in the right. So we can confirm this by running the code. And yes, the value 99 got inserted at the second position in the vector. So this is how we can insert a single element inside a vector. What if we want to insert multiple elements inside the vector? Suppose we want to insert 3 elements at the beginning of the vector and each element will have value 100. For that, first we need to pass the iterator pointing to the location where we want to insert the element, and in our case it's the beginning of the vector, so we will pass the iterator returned by the begin function. Then we will pass number 3 because we want to insert 3 elements and value of each element should be 100, and that will be our third argument. So it will insert 3 elements with value 100 at the beginning of the vector. We can confirm this by compiling and running the code. And yes, it inserted 3 elements at the starting of the vector. So this is the second way to use insert function to add multiple elements. In the third implementation, we can insert multiple elements from another sequence into the vector. Let's understand this by an example. Suppose we have another vector of integers and the name of the vector is second vec, and it has 3 elements, say 101, 102 and 103. Now we want to insert all these 3 elements at the beginning of the vector. For that we will call the insert function, and first we will pass the location where we want to insert the element, that is iterator returned by the begin, and then we will pass the start and end iterators of a range from which we want to insert the elements. In our case, we want to insert all the elements of second vector into the beginning of first vector, so we will pass second vector dot begin and second vector dot end. So it will pick all the elements in this range and insert them one by one at the given index position. Let's confirm this by running the above code. And yes, it added the 3 elements from the second vector into the beginning of the first vector. So this is how we can use the insert function to add multiple elements into the vector. We are going to discuss different ways to access elements in a vector. We have already created a vector here and initialize it with certain values. Now we want to access an element from this vector based on its index position. Indexing in C++ starts from 0. It means the first element of vector has index 0, the second element of vector has index 1, the third element of vector has index 2, and similarly nth element in vector has index n-1. So if we want to access second element of vector, we need to use the index position 1. Now the vector provides an operator square brackets that we can use to access the element. Let's confirm that. Vector object, and in the square brackets pass the index 1. So it will return the second element of the vector. We can confirm this by printing the element. Let's compile the code and run it. It returned 12, that is the second element of the vector, because we pass the index 1 here. So similarly we can access the element at the nth position by passing the n-1 index here. But this square bracket has certain limitation. What if we pass an index position that does not exist in the vector, like say 100? As vector has only 5 elements, so index 100 is out of range. So if we compile this code and run it, so it will return 0. Sometimes it will return any other number, sometimes it will return a garbage value, and sometimes application will crash. So if we provide any index position that does not exist in the vector inside the square brackets, then the result will be undefined behavior. We cannot predict what will happen. So it's a risky way. So we can avoid this problem, that is using the add function. And instead of calling the square brackets, we will call the function add. In the add function we will pass the index and it will return a reference of the element at that particular index. It should print 13, and yes, it printed 13 because we are trying to access the element at index position 2. This is 0, 1, 2. The index position 2 has element 13, so therefore the add function returned 13. Add function looks similar to the square bracket, but it has an additional advantage. If we provide an index that does not exist in the vector, then it will throw an exception. Check it out. We have provided the index 100 here and we are trying to access the element at index position 100. If we run this code, it will abort the program by giving an exception out of range. So we should always use the add function inside a try catch block. So what will happen here, we will try to access the element at index position 100 and add function will throw an exception and the code will go to the catch block. Inside the catch block we have printed the exception, and after the catch block we are printing another line. Code ends here. So let's run this code. So we tried to access an element at index position 100 which is out of range. So add function threw an exception which got catched in the catch block and we printed the error, and after that it moved out from the catch block and printed the last line. So our code executed completely. It didn't crash the application. Now let's see how to iterate over all the elements of a vector. So here we have created a vector of integers. Now we want to iterate over all the elements of it. For that we can use three different techniques. Let's discuss them one by one. First is using the range based for loop. In this we need to provide a for loop statement, and in the statement we need to provide the variable and the vector object separated by a colon, and then the for loop body. So what this for loop statement does here, that it executes the for loop block n times, where n is the size of the vector, and for every iteration it will pick the element into this variable, and we can use that element inside the block. For example, in the first iteration the value of this variable will be 11, and the second iteration value of this variable will be 12. Similarly, in the third iteration value of this variable will be 13, and so on. Now this for loop will iterate over all the elements of vector and print each element in the vector. We can confirm this by executing this code. Yes, it printed all the elements of the vector separated by a comma. So this is called a range based for loop. It got introduced in C++11, but there is one drawback here, that we don't get the index of the elements. During iteration. Like we know that in the first iteration element points to the first element of the vector, but we don't have its index position. So there is another old way to iterate over all the elements of the vector. For that, let's remove this element and we will change the for loop statement. In this statement we will iterate over all the elements of vector using indexing. So we will start with int I equals to 0 until I is less than vector size, and keep on incrementing the index. And during the for loop block we will access the array element using ith index position. Oh, our vector name is numbers, so yeah. So in this for loop we will iterate over or loop over all the vector elements using its index position. So as indexing in vectors starts from 0, so index position of first element is 0. So when this block is executed first time, it will print the first element of the vector. In the second iteration, value of I will be 1 because we are incrementing it. So in the second iteration, it will print the second element of the vector, that is element at index 1. So similarly, using index position, it will print the elements. We can confirm this. So it printed all the elements of the vector. In the for loop block, apart from the value of the vector, we have another extra information, that is the index position. So we can print that also, like here, element at index position I. So here we will print the index position and the value at that index position in the vector. Now we don't need this. If we execute this code, it will print each element of the vector and its index position in a separate line. Like here, index position 0. Like here, element at index position 0 is 11, element at index position 1 is 12. So when we need the index position during a for loop, then we can use this syntax of the for loop. How this is useful? Suppose you want to print the vector elements at index position, at even index positions only. So we can make a decision here based on the index position. Like if index position is even, then only print the element. If we clear it and rerun the code, so it printed the elements at the index position which are even, like index position 0, index position 2, index position 4 and index position 6. So when you are iterating over the vector using a for loop and you want to use the index of elements during iteration, then you can use this type of for loop to iterate over the vector element. How to remove elements from a vector? To remove an element from a vector, vector provides the function erase. It has two overloaded implementation. Let's discuss them one by one. In the first implementation, it accepts an iterator as an argument and removes an element from the vector pointed by this iterator. It removes the single element from the vector pointed by the given iterator and decreases the size of the vector by 1. It returns an iterator pointing to the element next to the last deleted element. We have a vector of integers here. Now we want to delete the third element from this vector. For that we need to get the iterator pointing to the third element of the vector, that is at index position 2. Now vector provides a function begin which returns an iterator pointing to the first element of the vector. Now we can increment this iterator 2 times to make it point to the third element of the vector. But STL also provides a function for this, STL, that is advance, in which we will pass the iterator and how many times we want to increment it. We want to increment it 2 times, so we will pass 2 here. So after this statement, iterator it will point to the third element of the vector. Then we can call the erase function of vector and pass the iterator into it. It should delete the third element of the vector, that is the element pointed by this iterator. We can confirm this by running this code. it printed the elements of the vector, but as you can see, the third element of vector got deleted. Or what we can do, we can print the vector initially, and then after deleting the third element, we can print it again. Clear the console, compile the code, execute the binary. So here we can see that initially all the elements of the vector got printed, but then we deleted the third element of the vector, and in the end when we printed the vector, it didn't have the element 13. So this is how we can delete an element from a vector based on its index position. Now suppose we want to delete 3 elements from this vector, like first 3 elements. For that we will use the second implementation of erase function. So this is iterator 1 pointing to the start of the vector. Now let's get another vector, iterator 2. Now we need to make this iterator 2 point to the fourth element of the vector, because for that we will call the advanced function and pass iterator 2 and value 3. Now iterator 2 will be pointing to the fourth element of the vector. Now we will call the erase function of the vector and pass it1, it2. Now erase function will receive these two iterator as the range. So it will start removing the elements pointed by the first iterator and removes element till the iterator pointing to the second element pointed by the second iterator. But it will not delete the element pointed by the second iterator. It will delete elements just before that. So this will delete the first 3 elements from the vector. We can confirm this by executing this code. It deleted first 3 elements from the vector. So this is how we can delete a range of elements from a vector. But in both these examples, we deleted the elements based on index position. First we deleted the third element of the vector, then we deleted a range of elements from one index position till the second index position. What if we want to delete element based on value? Let's see an example. Suppose we have a vector and it contains certain duplicate values, like here 11. Now we want to remove all the occurrences of element 11 from the vector. We don't know its index position, but we know the value that we want to delete from the vector. Now as we already discussed the erase function, both the implementation of erase function accepts the iterator. So here in the std remove we will pass the begin and end iterator of a vector and the element to be deleted. What it will do, it will not actually erase the elements from the vector, but it will shift. What it will do, it will shift the element that we need to delete it into the end of the vector. Like here in this case, it will delete this, it will shift this 11 to the end of the vector. Then it will again shift this 11 into the end of the vector, and the last 11 also it will shift it at the end of the vector. So our vector content will be like this after this statement remove, and it returns an iterator pointing to the first location where it has shifted the elements, like iterator pointing to this first 11. So we can store that iterator here. Now we know the iterator pointing to the first element that has been reallocated or that has been shifted. So now we need to delete this segment from the vector. For that we can use the erase function of the vector In the erase we will pass iterator IT, and as the second argument we will pass the end iterator of the vector. As iterator IT points to the first 11 here, so this erase will delete these 3 elements. So after this line erase, the vector contents will be like this. We can confirm this by running this code. It deleted all the occurrences of element 11 from the vector. This is also called remove erase idiom many times. So this is how we can delete an element from a vector based on value. If you like this video, then please don't forget to subscribe to our channel and press the like button.